The vertical line test is a method used to determine whether a given graph represents a function. It involves visually inspecting the graph and checking if any vertical line can intersect the graph at more than one point. If, for every vertical line that is drawn through the graph, it intersects the graph at only one point, then the graph represents a function. This means that for each input, x value, there is only one output, y value. In other words, it satisfies the criteria of a function, where each input has a unique output. However, if there exists at least one vertical line that intersects the graph at multiple points, then the graph does not represent a function. This indicates that there are multiple outputs, y values, for a particular input, x value, violating the definition of a function. The vertical line test is a useful tool to quickly assess whether a graph represents a function or not. It is important in mathematics and various fields that rely on functions, such as calculus, physics, and engineering. Here are a few examples to demonstrate the vertical line test. Example of a function. Let's consider the graph of a simple linear equation, y equals 1/5 x plus 1. When we plot this equation on a coordinate plane, we get a straight line. If we draw any vertical line through the graph, it will intersect the line at only one point. Therefore, this graph represents a function. Example of a non-function. Now let's consider the graph of a circle, x squared plus y squared equals 4. If we plot this equation, we get a circle centered at the origin with a radius of 2. If we draw a vertical line passing through the graph, it will intersect the graph at 2 points, one above and one below the x-axis. Therefore, this graph does not represent a function. By using the vertical line test, we can determine whether a graph represents a function or not based on how the vertical lines intersect the graph. Thank you.